Hello, a pleasant day to everyone. I'm Luvanya Sri from Bmid. My metric number is B0922103775. So we are here to propose our task, which is we need to construct an object that can be done by the LATHE operation and generate by the Sinutrain coding system. So our team decided to use SolidWorks in software to build an aviation engine component, then create the part by Sinutrain code following to the coordinates of the drawing as well. So today I would like to discuss the project on how to generate the code, how it works and where it used and so on. So in this project, me and my another 3 group members contributed as well to complete this project. To shortly introduce our project, we choose aircraft engine component, which is used in commercial aviation, play a vital role in the operation of airlines in the flying experience of passengers. So when we talk about the aircraft engine, it is the component of the propulsion system for an aircraft that generates mechanical power. And also aircraft engines are almost lightweight piston engine and gas turbines. There are some example engine used in aviation include piston engine and jet engine, and another one is turboprop engine. So in commercial aviation, there are 2 main types of engine are used, which is jet engine and turboprop engine. So the jet engine is mainly used in commercial aviation for long-haul flight and large aircraft. And another one, the turboprop engine, is mainly used in commercial aviation, especially for the regional and short-range flights. Furthermore, an aircraft engine is made up of cold and hot section. The cold section includes the intake, bypass, diffuser, duct and compressor. Meanwhile, the hot section consists of the combustion chamber and turbine, nozzles and exhaust. Also, aerospace parts are those needed to operate machines that shape and transform the metal aircraft components. So these parts are likely to be called as aircraft accessories in this project.
Hi, my name is Nilena Vatisha with Bmid. My metric number is 0922103703. Today, I would like to present you about our objective for this project. For this project, our objective has 3 main objectives. For the first one, to enhance detailed understanding and hands-on experience using ISO CNC programs. Second, to treat product utilizing ISO CNC machining. And third, to identify and apply important machining techniques, resource, and knowledge. That's all for me. Thank you.
Hi, this is Kelly. So I'd like to present the methodology of our project. So the methodology for this CNC project starts with project planning and design. This phase includes selection of ideas and creating detailed drawing including dimensions by using CAD software. And here we are using SolidWorks software to create our drawing of project. After that, by using Sinutrain software, we generate a G-codes program to specify the toolpath and machining parameters necessary for the CNC lathe operations. The CNC lathe is then set up for the machining operation. To make sure it is appropriately aligned and operating, the machine is inspected and calibrated. So after everything is set up, the machining process starts. In order to maintain the appropriate level of precision and accuracy, this process is continuously observed and adjusted in real time as necessary. And at the next slide, our member will show us a more detailed process flow of our project.
So next for process flow, the first one is working with team members and choosing a suitable design for the project proposal. Next, by using SolidWorks to construct the project design and define dimensions for all designs. Submit all ideas for selection. Number 4 is once one design had been finalized from the product coordinates, then started to generate code for the LATHE process using Sinutrain. Hand in the coding to the lecturer for checking. After confirming, fix any mistakes that exist, then schedule a workshop time to cut the materials. After cut the raw material, carry out the LATHE working in the CNC lab, and lastly, submit the project, parts and report together.
So beginning of this project, we were given the raw material, which is size of diameter 50 mm and the length is 150 mm. So when we given the raw material, we decided to come up with the aerospace engine part, and to create this object we used the SolidWorks software to create these objects as well. So once I created this object, I constructed the dimensions as well to make it more easier when coding generating process.
Hi, my name is Kelly. So I'm now going to present the Sinutrain code of our project. So our G code can separate into two parts, and this is because our project involves a step that need to turn the direction of workpiece in order to get the desired shape as in our drawing. So let's look at the first part. So firstly, we did a facing step, and then followed by the counter turning to remove the external material of our workpiece. And then here also we do a roughing process, and then lastly we do a finishing at the front part of our workpiece. And then followed by the next slide, we go to the second part. So after completing the part 1 coding, we take out our workpiece and clamp it at a vice versa direction, which is here. Clamp at here, and then we remove this back part of our workpiece manually by the guidance of lab assistant. So means that we run this second part coding after we remove the back part of our workpiece. And then in the second part coding, we do a roughing process by using left plug cutter to remove the external material of workpiece, and then followed by a finishing process to get our desired shape as in the drawing. And then finally we complete our project. So here showing our project result after machining process. So the picture at left hand side shows the project just after complete part 1 program coding, and the second picture shows the final result of our project, and the shape and dimension is just same with the drawing.
So as a result, actually there was a minor issue we experienced throughout the code generation process, which is at the corner and the chamfer curve. So there must be a need to change the tool at the center coordinate and create a chamfer after the radius. So to solve this, we were guided by our instructor and watched some YouTube videos to change the tool and create the required shape based on the coordinate as well. Furthermore, when doing the second simulation, the code contains error due to the incorrect cutting tool selection and also due to the issue we faced having coding problem while machining. So we overcame this issue and completed our goal as well. And also the time estimation for the complete lathe process in the simulator is different from the actual machine because it took longer time for machining due to the cutting tool can't handle the high speed and coding error.
For conclusion, based on this assignment project, we learned about how to write a proper coding program for CNC lathe machine. We learned on how a team will do in working on this project. Try to set up the machine and do a discussion together with lecturers so that we can learn this project properly. Try to maintaining the appropriate level of precision and accuracy of CNC lathe machine while doing this project. Read the dimensions from drawing and try to apply the dimensions in programs so it can cut the material correctly and properly. Searching for an error in our program while doing the program for our lathe CNC machine project. That's all from me. Thank you.